Hello everyone, let us see two more examples on divided difference formula. In the last lecture I have solved two examples on divided difference. Let us see the third one. Find the cubic polynomial which passes through the points 2, 4, 456, 957, 10, 980 and hence estimate the dependent variable corresponding to values of the independent variable 3, 5, 7, 11. Here we have to find the solution for 3, 5, 7, 11. 3, 5, 7, 11 means we have to find here what is the f of 3, f of 5, f of 7 and f of 11. Here they are given the order pair. We know that this is of the form x comma y, x comma y means x naught, y naught, x1, y1, x2, y2, x3, y3. We have to find f of x where we have by data f of 2 is equal to 4. X naught is 2, y naught is 4 and f of 4 is equal to 56, f of 9 is equal to 711. So that it here also it is 711. Then f of 10 is equal to 980. The divided difference table is, see here we have to find the solution for 4 different values. So the better is first find the interpolating polynomial, then substitute 3 to get f of 3, substitute 5 to get f of 5, to find f of 7 substitute x as a 7 and to find 11 f of 11 substitute x as a 11 instead of calculating separately for all the 4 numbers. Okay, let us find the divided difference table first. And x naught is 2, x1 is equal to 4, x2 is equal to 9, x3 is equal to 10. The corresponding values, f of x naught is equal to 4, f of x1 is equal to 56, f of x2 is equal to 711, f of x3 is equal to 980. These are the given values. You already know how to find the remaining values. Today directly I will return the term. When you calculate this as f of x1 minus f of x naught divided by x1 minus x naught, you get it as 26. Next for here formula is f of x2 minus f of x1 divided by x2 minus x1. When you calculate we will get it as 131. Next one is f of x3 minus f of x2 divided by x3 minus x2. We will get 269. Next here the formula is what? F of x2 comma x1 and x0 comma x1 divided by x2 minus x0 is 15. Here f of x2 x3 minus f of x1 x2 divided by x3 minus x2 is what? 23. Similarly here f of x2 x3 x4 minus f of x0 x1 x3 divided by x3 minus x2 is 1. Is 1. Next go for the formula. We have the divided difference formula is like this. Here also we have the terms up to third divided difference, so that I have written here in a general formula I have written up to the terms of third divided difference plus and so on. Now substitute, since here we are finding first interpolating polynomial, because we have to find the solution for 4 different numbers, better we have to find the interpolating polynomial first. It will be f of x is equal to, substitute the values, 4 into 4 plus x minus 2, this is 26, plus x minus 2, x minus 4, This is 15 plus x minus 2, x minus 4, x minus 9. The last one is 1, which is equal to 4, plus in all the remaining terms we have x minus 2 common, 26, plus simplify this one, we get 15x minus 60, plus simplify this two, what we will get, x square minus 13x plus 36, okay, which is equal to 4 plus x minus 2 is equal to 26 plus 15x minus 60 plus x square minus 13x plus 36. Simplify this one, we get 4 plus x minus 2 into x square, 15x minus 13x is plus 2x, 26 minus 60 plus 36, 26 plus 36 is 58 minus 60, sorry 26 plus 36 is 52, so 62 minus 60 is plus 2. Our polynomial is x cube minus 2x. When you simplify this one, you will get f of x as x cube minus 2x. Otherwise, I will write the next term here, 4 plus, simplify this one, what we will get, x cube plus 2x square plus 2x minus 2x square, I will write here below, minus 2x square minus 4x minus 4. See here, x cube is as it is, plus 4 minus 4 get cancelled, minus 4x, here we have plus 2x, plus 2x minus 4x, remaining is minus 2x, plus 2x square minus 2x square get cancelled. Therefore, our f of x polynomial is x cube minus 2x. Now we have to find what will be f of 3, f of 5, f of 7. Directly I will write this solution here. When you substitute x as 3 in this equation, you get 21, and f of 5 is equal to 115, f of 7 is equal to 379, f of 11 is equal to 1309. These are the values you obtain when you substitute values of x for the particular solution. Next example, using Newton's divided difference formula, find f of 8, f of 15 from the following data. The data is given, the x values are given, corresponding functional values are given, that is f of x is equal to y. I will write the difference table first. It will be 48, 100, 294, 900, 1210, 2028. Now find the remaining tables. This is 52, 97, 202, 310. Since I have solved 3 examples, here I am directly going for the values which we are obtained by calculating the f of x0, 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 x1, x2, x2, x3, x1, x2, x3, f of x3, x4 and x5. And here we have 15, the next term is 21, 27, 33, here we have 1, 1, 1. Since all are same here, the next is 0. Not necessary to draw this one. Simply understood that if all the values are same in one column, the next column will be 0. Okay. Here also we have to find the value for two different functions, that is f of 8 and f of 15. Since two values are to be found, we prefer to find the interpolating polynomial f of x instead of applying formula twice by taking x is equal to 8 and x is equal to 5 separately. See, I am taking formula here and substitution. On simplification, we get f of x is equal to x cube minus x square. To find f of 8, just substitute wherever x is there, substitute 8, you will get f of 8 as a 448, and substitute 15 for f of 15, you will get 3150. This is how you have to calculate using Newton's divided difference formula. The next concept is Lagrange's formula for interpolation and inverse interpolation. Next method is Lagrange's method. Lagrange's formula for interpolation and inverse interpolation. Statement: if y0 is equal to f of x0, y1 is equal to f of x1, y2 is equal to f of x2, and so on to yn is equal to f of xn, be a set of values of an unknown function y is equal to f of x corresponding to the values of x, where x values are x0, x1, x2, so on to xn, not necessarily at equal intervals. Okay. Divided difference method means divided difference formula is also applicable when x values are not having equal intervals, and Lagrange's formula is also for unequal intervals. Okay, Newton's forward and Newton's backward interpolation formula is for equal intervals, whereas Lagrange's divided difference and Lagrange's method for unequal intervals. You have to remember this. Next, the formula is y is equal to f of x is equal to x minus x1, x minus x2, and so on to x minus xn into y0 whole divided by x0 minus x1, x0 minus x2, and so on to x0 minus xn, plus next term is x minus x0, x minus x2, x minus x3, and so on to x minus xn into yn divided by, so y1 divided by x1 minus x0, x1 minus x2, x1 minus x3, and so on to x1 minus xn, plus x minus x0, x minus x1, x minus x3, and so on to x minus xn into y2 whole divided by x2 minus x0, x2 minus x1, x2 minus x3, and so on to x2 minus xn, and so on to the nth term is x minus x0, x minus x1, and so on to x minus xn minus 1 into yn divided by xn minus x0, xn minus x1, and so on to xn minus 1. This is our general formula for Lagrange's method. Okay. Since this is general formula for nth terms, it seems very big, but when you solve for the examples, it is very easy. Okay, but you have to perfect which values are taken for numerator and denominator for the particular first, second, third, and fourth, and so on terms. Remark: the special feature of this formula is that the terms of the formula involve only the values in the variable x and y only. Okay, this is the special feature of this formula. The values of x also need not to be equally spaced, nor need they may be in any order. This is known. We can interchange the role of x and y in the formula, and the same is called Lagrange's inverse interpolation formula, which helps to find x for a given y. From this formula we can find the Lagrange's inverse interpolation formula. Just the interchanging the role of x and y, means wherever x is there, write y, and wherever y is there write x. You will get the Lagrange's inverse interpolation formula, which helps us to find when the value of x is given. For that we have to find the value of y. Then the Lagrange's inverse interpolation formula is what? X is equal to or f of y is equal to this one. Substitute wherever x is there, substitute y in Lagrange's interpolation formula. You will get the inverse Lagrange's inverse interpolation formula. See the difference between the Lagrange's interpolation formula and Lagrange's inverse interpolation formula. These two are very easy to remember. Just practice the formulas. Let us go to the example. Use Lagrange's interpolation formula to find f of 4 given x values are 0, 2, 3, 6. F of x values are -4, 2, 14, 158. See, in this method, first you have to write what will be the values of x and what will be the values of y. Then you can easily substitute the values, otherwise they may be confused. Okay. Let x0 is equal to 0, x1 is equal to 2, x2 is equal to 3, x3 is equal to 6, y0 is equal to -4, y1 is equal to 2, y3 is equal to 14, y4 is equal to 154, and here x value is given what? 4. For that we have to find the value of y. Correct? The x values is given, that is 4. For that we have to find the value of y. This is the meaning. We have Lagrange's interpolation formula for 4 given values. See, they are given 4 given values. Here we have terms up to y4. Correct? We have terms up to y0, y1, y3, y2, y3. This is correct. y3, x3, y3. But we have here 4 set of values. We have Lagrange's interpolation formula for 4 given values. Here our last values are x3 and y3. We have to write the terms up to x3 and y3 in our formula, mainly for y3, right? See, x minus x1, x minus x2, x minus x3. We don't have here x4, so that it will be x minus x1, x minus x2, x minus x3 divided by x0 minus x1, x0 minus x2, x0 minus x3 into y0 plus x minus x0, x minus x2, x minus x3 into y1 divided by x1 minus x0, x1 minus x2, x1 minus x3, and here the third term is x minus x0, x minus x1, x minus x3 into y2 divided by x2 minus x0, x2 minus x1, x2 minus x3 into y2 plus x minus x0, x minus x1, x minus x2 into y3 divided by x3 minus x4, x0, x3 minus x1, x3 minus x2. The next term will be for y4. We don't have here any value of y4, so just write up to x3, y3 terms. You have to write your formula according to the given values of x and y. Now substitute the values in this formula. We get f of x is equal to or y is equal to x value is 4, 4 minus x1 is 2, 4 minus x2 is 3, 4 minus x3 is 6 into y0 value is minus 4 divided by x0 is 0, 0 minus, here you can directly write x1, x2, x3 with negative sign, but since this is first example, I will write everything. 0 minus x1 is 2, 0 minus x2 is 3, 0 minus 6. Next term, 4 minus 0, 4 minus 3, 4 minus 6 divided by 2 minus 0, 2 minus 3, 2 minus 6 into y1 is how much? This is 2. Next term I will write here. Next x is 4 minus 0, 4 minus 2, 4 minus 6, and y2 is how much? 14 divided by 14, it is 3 minus x3, x2 is 3, 3 minus 0, 3 minus 2, 3 minus 6, plus 4 minus 0, 4 minus 2, 4 minus 3 into y3 is 158, all divided by, here it will be 6 minus 0, because x3 is 6, 6 minus 2, 6 minus 3. Okay, this is the substitution. Now calculate one by one. After calculation we get it as y is equal to f of x is equal to, sorry, not f of x, here value of x is 4, so that we have to write 4 in back also. 4, f of 4 is equal to, it will be, first term is minus 4 by 9 minus 2 plus 224 divided by 9 plus 158 divided by 9, which is equal to 382 divided by 9 minus 22 divided by 9 is equal to 360 divided by 9 is equal to 40. Therefore, f of 4 is equal to 40 is the required solution. F of 4 is equal to 40 is the required solution. Next example, use Lagrange's interpolation formula to fit an polynomial for the data x values are 0, 1, 3, 4, y values are minus 12, 0, 6 and 12. Hence estimate y at x is equal to 2. See here, first they are asking to find Lagrange's interpolation formula. Use Lagrange's interpolation formula to fit polynomial. Means first you have to find the interpolating polynomial. After that you have to find f of 2. Here you have to find the value of y at x is equal to 2, means you have to find f of 2. Before that you have to find the polynomial. See, first we have to write x values and y values, and this is our Lagrange's interpolation formula. Here also we have the terms up to x3 and y3. According to that you have to write the Lagrange's formula. Now substitute the values. Here x is added as it is, because first we have to find the interpolating polynomial. X minus 1, x minus 3, x minus 4. x1 is 1, x2 is 3, x3 is 4. y0 is minus 12. All divided by, our equality should be here. The next x0 is 0, minus 1, 0 minus 3, 0 minus 4 plus x minus 0, x minus 3, x minus 4, y1 is 0, here 1 minus 0, 1 minus 3, 1 minus 4. Next term plus x minus 0, x minus 1, x minus 4, and y2 is 6. Next x2 is 3. 3 minus 0, 3 minus 1, 3 minus 4, plus x minus 0, x minus 1, x minus 3, and y3 is 12 whole divided by 4 minus 0, 4 minus 1, 4 minus 3, 4 minus 3. Now simplify this one. Here keep x as it is because we are finding interpreting polynomial. On simplification, what we get here, x minus, see in all these terms, otherwise I will go to the next step, x minus 1, x minus 3, x minus 4 into minus 12 divided by minus 1 into minus 3 is my 3. 3 into minus 4 is minus 12 plus x into see x into 0 into something is the whole is 0. Here we have x minus 1, x minus 4 into 6 whole divided by, here 3 minus 0 is 3, 3 minus 1 is 2, 3 into 2 is 6, 6 into minus 1 is minus 6, plus I will write fourth term here, x into x minus 1, x minus 3 into 12 divided by 4 into 3. 4 3 is a 12. 12 into 1 is 1. Therefore it is 12. This minus 12 cancel with this minus 12. 6 cancel with this 6. 12 cancel with this. Here it will be, the next term is in negative sign. Our f of x will be what? F of x is equal to x minus 1, x minus 3, x minus 4 minus x into x minus 1, x minus 4 plus x into x minus 1, x minus 3. In all these three terms, what is common? Otherwise, which is equal to x minus 1. Take only one term, x minus 1 is common. Okay, in all this term only x minus 1 is common. X minus 1, here this will be x square minus 7x plus 12 minus, this will be, this is common, x square minus 4x plus, this is x square minus 3x. On simplification, x minus 1, x square minus 7 x plus 12 minus x square, minus into minus plus 4x plus x square minus 3x, which is equal to x minus 1 plus x square, 1 plus x square, 1 minus x square get cancelled. The remaining is x square minus 7x plus 4x minus 3x, means minus 10x plus 4x is there. It will be minus 6x plus 12, which is equal to, simplify this one, x cube minus 6x square plus 12x minus x square plus 6x minus 12, which is equal to x cube minus 7x square, 12x plus 6x is 16x minus 12. F of x is equal to required required polynomial, which is our required polynomial. Now f of 2 is equal to 2 cube minus 7 into 2 square plus 18 into 2 minus 12. Therefore f of 2 is equal to 4. Thus f of 2 is equal to 4. This is how you have to calculate first interpolating polynomial. After that, find the value of y at x is equal to 2, that is f of 2 is equal to 4.